Welcome to the lecture number 32. So I will start from wherever I left in the previous video. So in the previous video, when we closed, I talked about there is going to be two kind of cells depending on what kind of command is actually being put on the circuit. One is a control cell, so which will be on that particular hop. The whichever node which is receiving the control cell will immediately interpret it actually. And the relay cells are nothing but something which has to go through all the way to the endpoint of the circuit which has been created. So when it can no more further be forwarded, this is what is going to interpret what's there inside the relay cell. In fact, this is the only guy who can interpret because others can't, because it's in the encrypted form till it reaches to the last onion router in the circuit. Okay, the circuit which has been created by the user, the onion proxy all the way to the exit router. Okay, so this is basically end-to-end stream data. And this one is basically for the node which is receiving it. This is a control information is for that. So the lecture 30 is essentially now for the Tor and moving over to anonymous browsing. So let's start on this. So we have to now move ahead with the cell structure to understand this phenomena, how the circuits are being set up, extended, dismantled, and how actually exactly the browsing happens. So the control commands which are available for the control cells, so let's discuss them one by one. So they are actually one command which is padding. So this is normally used for just ensuring that sending a message keep alive, that you are alive, just informing this thing to other endpoint. So when there is no communication happening, that time this can be done. And this can be used for doing padding. So basically you are actually padding extra cells for communicating so that somebody who is trying to do traffic analysis will get a wrong information. Okay, it is not going to be commensurate to what actually you are communicating. So you can put in dummy cells inside it. It's basically used for that purpose on a link between two onion routers or onion router or a proxy is for that purpose. Second is a pair. So when a forward request is basically to create a circuit, is a new circuit creation, it's basically a request for that. And when that confirmation comes from the other side, other end, so if this guy will want to set up a circuit to this onion router, it will be going to send a create. Okay, and this will send a created. So as a consequence, when this is done, they will both will be able to now build in this process a symmetric key, which is only known to these two people. And this can be then used for encrypted communication between these two nodes. Okay, so there is a create and created, which is a confirmation message which comes in the back. And then there is a destroy. So you can destroy a circuit and totally dismantle it. It's basically tear down of the circuit for that purpose. So circuit ID and then destroy command, if it is there, that circuit ID will be destroyed by the other endpoint. Basically data structure will be cleaned off. After that, if you use that circuit ID, the other guy will not be knowing what to do. It will simply discard it. So it's a tear down the circuit. It's for that purpose. Now relay cells, which is the other kind, will consist of many possible options. So normally relay cell will actually have another additional header, and this additional header will be there in the front of the payload. Okay. So when the way it is going to happen is I should actually draw the cell structure now. For command cell, it will look something like this. So this is a cell. The first part was circuit ID. Now this is going to consume 2 bytes. So that's a Tor version 2 standard actually tells. Is basically specification with which Tor was implemented. There is no standardizing body. It just was implemented by volunteers. Is their spec. So you can actually decide your own thing if you are implementing your own stuff. Command always requires 1 byte. Okay, so 1B, and 509 bytes are required for whatever is the data which is required by this command. Is for that. Okay, total 512 byte cell which is there. This is the control cell. For relay cell, before I move on to various relay commands, will consist of again a circuit ID, which is again 2 byte. Now this 1 byte is a command field, but the value here will not be command actually. The value here will become relay. So I will change this. So we will have a relay here. So 1 byte. So relay is a special kind of command. If these are not there, relay will be there. And then whatever is there, it's not purely data. There is going to be now a header which is going to be for, this is what we call relay header. And this is the additional header. So this header was already there. There is additional header which is going to be there. We call it a relay header. And then there is a data which is going to be there. So relay header will have again a first field will be stream ID. So remember, within a circuit there can be multiple TCP streams going. So exit node may be actually then setting up connections to different servers TCP streams. So they all are being multiplexed. So this is stream ID basically used for this multiplexing purpose. So we use 2 bytes for this stream ID. Then there are 6 bytes which are used for digest. Now this is one of the important field. So from this point onward to till this last point, this whole thing is always encrypted when it is being sent. Okay, this is never encrypted. This part is always encrypted, can be encrypted multiple times because of the onion structure. Now this digest is essentially over this whole period. So if this digest, actually if you read these 6 bytes and they match with the digest value here, of course this is not a straightforward digest, they use also a digest state at both sides, so that nobody can actually to avoid certain kind of attacks. Okay, so this digest, if it matches, then this everything you can interpret. If this digest bytes are not matching, then this must be still in the encrypted form and you may have to forward it. So a node can identify whether this has already all encryption layers have been removed or not. So when it's the first layer, it will figure out, it will check for the digest not, so it has to look into the table. This circuit ID on this side must have been mapped to something, so it will forward on that as it is after decryption. It comes here, it will also check for the digest. If digest actually matches, then of course the circuit is now ending here. It has to do something with this tree. It has to interpret what is there in the relay field, relay header, and based on that take the action, whether data has to be relayed or it has to be extended. Okay, if it is not, again digest is not matching, it has to look into the forwarding table, find out the circuit ID here has to map to which circuit ID to which particular node. Okay, based on that, this whole thing will be further forwarded. So only circuit ID field will keep on changing as you are moving the cell ahead. So this is how actually we figure out the last node, always the exit node will find out the digest is matching, and henceforth it will figure out what has to be done. So it may be simply relay the data onto the TCP circuit. It will simply push on the data to the TCP circuit. Reverse side data will come. Again the same procedure. It will say the data is coming on this circuit. It has to be converted to transferred to this circuit. But I have to do a encryption. So it will use the same encryption which is being set up between source and this node. So I will talk how that will be done further. So it comes here, it will again do another encryption depending on what is the key between this and the source, and another encryption on this side between whatever is the key between this and source. And once it comes to onion proxy, it will actually strip down one after another all the layers till it finds the digest matching is there. Then there is no more encryption is required. So cyclically it will just keep on doing it. Okay, and it knows that this circuit has been set up with these many relays, so it knows this has to be done these many times, and digest should match after that. And then whatever is the data, that simply will be transferred over a TCP circuit to the application. Okay, that's how typically it is done. So now this circuit will have a stream ID, digest, and then there is a length field, so which gives the length of data. So you may not all the time transmitting full, so some of the time it will be less also. So maximum value will be 498 or less. That value will be represented by this length. Okay. So these are 2 bytes which is required for 498, because with 8 bytes you can only go till 255. So 2 bytes are represented here. Then there is a 1 byte which goes for command. So this is a relay command. So there are various commands. Let's list them down. What are those? So you will have, just before moving over to commands, as I mentioned, this will be encrypted. As I mentioned, this whole thing will be encrypted actually as it keeps on moving. So this is only being identified. Relay header will only be known at the end node or only at the source node when it comes in the reverse direction. Now important thing is that how this encryption will be happening. So for this they use AES counter based 128-bit AES encryption is a key thing, and then it is going to be using a counter mode. So what does it mean is that this whole stream, whatever is being transmitted, so both source and destination with source and the onion router, onion proxy and onion router within which the encryption has to happen, will actually have something called nonce. They will actually generate in the beginning of the session. Then they will use a counter. This counter will be incremented, and this whole byte will now be encrypted with AES encryption. So AES encryption also takes in the key. So key is a key which is being agreed between them. It's an ephemeral key generated through onion keys using TLS mechanism, transport layer security. And this is what is the being XORed with the message. So first 128 byte of this particular thing will be put here, and I will get the ciphertext. Then I will take the next one is a nonce plus the counter value will be incremented now by 1. It will be again going through same thing. Okay. Now this nonce will keep on changing every time before the stream starts. Once it is there, just for that stream it will be just used. So both sides will keep track of their nonce. Okay. So this counter will keep on going, and then after that it will repeat. And most likely before that the stream will get closed, and then of course when the new stream is set up, this nonce have to be essentially negotiated by both. It's a random number basically which is done, while key is maintained as same. So this one will be coming, and then I will do the XOR with the message part 2. So next 128 bits will be taken now, and so on. So you keep on doing it, 128 bit at a time, 128 bit at a time, and so on. So that's how you kind of create a stream cipher out of the block cipher actually. So this is going to be new ciphertext. So what you transmit is C1, C2 and so on. So your message sequence M1, M2, M3 and so on will get converted to C1, C2, C3 and so on. The number of bytes which are there will remain the same. Okay. So this is done with the key. So between first onion proxy and OR1, we will be using key 1 actually, which will be used for doing this encryption. So whatever is C1, C2, C3 which you have got, now onion proxy 2, onion router 2. So in fact, there is the last one, onion proxy 2, onion router 4 for example in our case, this is the exit router. So first of all this encryption will be done. So message will be converted to C1, 2 and so on, and this will be encrypted. So message will be encrypted to this. So this will be now with onion router 3. So this is the forward direction going from onion proxy to exit router. This will be converted to another kind of thing. Now the number of bits here remains the same, they don't change. So 498 bits will always be encrypted, and this will be the for the with OR1. Okay, so it will be always in reverse order. So as they go along, so decryption will be happening. Decryption also is very simple. This nonce has to be known to the other end, which is decrypting. It will just create this particular string by doing this encryption. Simply it will now do C1 will be XORed with whatever is the bit string which you are generating here, the same will be fed here, and then I will get message back. So this is a reverse path which will be done. So this basically what it means, that 128 bit based AES counter mode operation for encryption and decryption which is being done. They don't use cipher blockchaining. Okay. So the important thing is that I need not, there is no dependency. I can just simply start and compute this particular block can be decrypted independently of this. Okay. Only thing, this is the random thing and the counter value. So I should know which segment I am decrypting. So non-linearly I can go to any place and decrypt it without decrypting the earlier portion. That's a big advantage and it's basically used for that purpose. Now coming to the relay commands which are available. So commands which are going to be put here as 1 byte in the relay header. So we will have the first basic command is going to be relay data. So this technically means you simply pass it on. Okay. Now remember, this relay data will be only interpreted by the exit onion router. Nobody else will be knowing it. It's a relay data field. Okay. So because so far you don't match, you don't get your hash value, the digest is not matching, you simply have to keep on forwarding. This relay data will now push this data back into a TCP stream set up by the exit router to the server. Okay. It will just simply pass it on to that. That's a relay data. Doing relaying is for that purpose. So you can call it is for the relay flowing down the stream, relaying the data flowing down the stream. This will happen on both sides actually. So from exit onion router to the onion proxy also similar thing will be there, and also in the forward direction also it will be there. Then we have relay begin. So you have already created somehow a circuit all the way to the exit router. Now you have to set up a new stream connecting to some server on internet. The TCP connection has to be done. So there is a relay begin command which is used for this. This is basically to open a stream. So this directly, remember, is the communication. The relay commands are being directly between onion proxy and the exit router. It's only communication between that. Okay, intermediate guys will not be knowing it. Then if you want this to open the stream, so there has to be something to close the stream. So we will have relay end to close the stream, and then we will have relay tear down. So this is basically to close a broken connection. So it has to be essentially communicated to somebody, whichever node, and that node then can close a broken connection. In that case, basically used for that purpose. We'll see how this also works. Then there is a relay connected. So when you do relay begin, so the response will come as relay connected actually. This is to notify, to tell the onion proxy that relay begin has succeeded. Okay. Then we have some more. So we have relay extended. So you already have created the 2 or 3 hops you have created. You want to create a 4th hop. This basically you will now do the extension. So you will just talk to that particular till that node, and then that node will be communicating directly to him. And then you can extend your telescopic encryption from there and extend the circuit. So it's for that purpose. So you make a request for extension, and the response will be with, if it's a confirmation, it's to relay extended. It's basically to extend the circuit by 1 hop. So 1 hop at a time the extension happens, and this one is to acknowledge the extension. Extension is happening. Then we have relay truncated. Relay truncate. So something which is there, you want to actually truncate a circuit. So for some intermediate node, you can actually send a relay message. You can relay directly to that guy. Remember, relay message is only to the intended onion router. In between routers will not be knowing. Okay. So relay command is always between 2 neighboring routers. So relay truncate will be sent to it, so it can truncate whatever is the circuit which has already been extended from that point onward. It can be used for that purpose. So this is to tear down the part of circuit. Then we also have to implement something called flow control. So for that, relay send me is normally sent by the exit router to the onion proxy to tell that, okay, don't send me now because I am already full. I am not, because I am now relaying it to some TCP circuit, piping it. So I don't have that much of buffer, or other guy is not consuming, you slow it down. It's basically used for that purpose, how much to send. And on the reverse side, onion proxy can always tell the router, which in turn then can communicate it over a TCP connection to the server actually from where, or the any other endpoint on the internet. Okay, remember in our scenario there is an exit router and then we are on the normal internet communicating to some endpoint, and this is the onion circuit, and then there is onion proxy, and then there is your normal application. Normal application had an option to go through internet directly and then communicate to server, but then it's not, anonymity is not maintained. So for anonymity I am using this Tor network. Okay, so relay send me is for that purpose. Similarly, there is a relay drop. So relay drop is to essentially basically for long range dummies. So you send all the way to some node, whichever is the target node. Till that point you will send the packets and then they will be dropped. Basically is essential to create a mismatch between the traffic. So you can't do traffic profiling and cannot generate information out of that. It's basically for that. Now there are certain important things when you create any Tor circuit. So one circuit which has been created can be shared by many TCP streams. Okay, so each circuit, so there is an important thing. Each circuit is shared by many, can be shared. So I should write can be shared, need not be, can be shared by multiple TCP streams which are originating from the same source. So you are actually, for example, communicating to multiple internet points. So you actually use this circuit to go to the proxy, and that from there it is going to that particular place. So everybody in the internet will actually see you as that person's IP address and port number. Your actual port number is not available. So that multiplexing happens because of the stream ID which is there. Okay. And of course, circuits are not being, you don't wait for circuits to be created. Circuits are created preemptively. That's very important. So what does it mean actually? That if you are there, you don't wait for something, you just create some circuit after identifying this is your exit router. Circuit exists, at that time some new TCP request comes in, you will now set it through this tunnel all the way to this exit router, from there to internet, okay, and to a server. Meanwhile, you actually after 1 minute, roughly you will create another circuit, you will forget this one. So every 1 minute you have to now create this, basically rotating the proxies we call it. So you get new circuit. Now whatever new request will be coming will now be exiting from here and then going to internet and then to the server. So when all the TCP circuits are closed on this circuit, this whole thing will be dismantled. This circuit will be dismantled. And you keep on generating new circuits without waiting for this thing. And any new connections will always go on that. So user won't feel the pinch when they are communicating. They don't have to wait for the new circuit to be created first and then the routing will be happening. So whichever is the currently available one, it will just simply use that, and you keep on dismantling older ones when they expire and keep on creating new ones, and all new sub-TCP circuits are always through the new Tor circuits which have been created. Okay, so circuits are being created preemptively, that's what it means. And user's onion proxy's job is to build new circuits periodically, so one every 1 minute actually. And they are all being using multiplexing, so multiple TCP connections can pass through one circuit, so it does not matter. So they will be actually carrying multiple of them. So this periodicity is 1 per minute actually. And of course the earlier one will always be dismantled only when all TCP circuits from here are closed. If any one of them working, we will maintain that TCP circuit. So onion proxy has to take care of this particular scenario. Now the advantage is this performance advantage is there for the user. He won't feel the pinch of this circuit, Tor circuit rotation will not be affecting the performance of the for the application which the user is running. So they are all being built up and they are torn down in the background. Now let's see how this actually process happens. So let's look at that Alice is there. Alice is the user. So onion proxy is running with the Alice. So I can call it onion proxy. Okay. So with the Alice, then I am only taking here 2 onion routers. I can take it even 3, does not matter. Okay. The paper which I am referring is about Tor version 2, basically from the Tor browser torproject.org. From there you can download the document also as well as the application both. Okay, so so there the example gives the actual 2 onion routers. I can do it with 3, so let me do it with 3. So from the paper anyway you can get it for 4 also. Can get it for 2. It's already pre-done, but let me do something different. And this is a website on the internet. So onion router 3 is the exit router. So Alice somehow first of all connects to the directory. From there it will get the list. It will pick up description of the routers and will decide, okay, which websites I would like to communicate. Based on that it will choose the routers, and it has to choose such that they all are able to take care of the bandwidth for that, which is being expected to be used by application of the Alice. Okay, and their exit router OR3 is willing to go to that website to the other side. I might have other criterions, maybe only choosing from certain countries the onion routers. Okay, and maybe I will look at the round trip time delay between OR1 to OR2 to OR3 kind of thing. So, and looking at all the information in the directory. So Alice will decide on OR1, OR2, OR3, what are they. So Alice knows their IP address and port numbers on which the communication can be made directly. So Alice will not directly talk to each one of them. Alice will only talk to OR1, and from that OR1 will be acting as a proxy through which it will then go to OR2, and then OR2 will act as a proxy through which it will create OR3. That's what we call extension of telescopic extension of the Tor circuit. So the Alice with the first step will now send remember there is a Tor control cell. So the control cell will be sent. So control cell we have option called create. The Alice now knows about OR1, OR2, OR3. So their IP address and port numbers, and there of course onion keys are available to Alice. So she will retrieve it from directory server. So to set up a Tor circuit all the way to the exit router and then to communicate to website, there is a process. So Alice will first of all use a path to be created to OR1. So it knows OR1's onion key. So it will send not a relay cell, but here a command. There is a control cell which will be sent. So this will be going to this point, and it will be a command cell. So this will be having a create. Create is one of the commands which are available in the control cell. It will be using that. It will also then identify which circuit number is available here. So it will say C1. Now it will also use the private key part of the onion key to send its own secret GX, which I can write it like this, e raised power GX1. This will be used to create key 1 K1, which is going to be for communication between onion proxy and onion router 1. So once it reaches here, only OR1 can decrypt this G raised power X1 because it knows the corresponding private key. It will now create another random value, which is going to be G raised power Y1. Now even if it is known to somebody else, does not matter, because unless they know G raised power X1, they can't make the key which is being used, ephemeral key, which is symmetric key between OP1 and OR1. Okay. So this will be sent back. It will be there. The corresponding confirmation command is created, and the circuit ID will be C1. So this will be sent back. So onion proxy will, and of course there will also be one more thing. The hash value of the key which has been created by combining G raised power X1 and G raised power Y1 by OR1, that will also be sent back. Alice will also create the same key, so it will compute the hash of K1. If the both hashes match, so it has been done successfully. That's a Diffie-Hellman handshake being done between onion proxy and onion router. Now the symmetric key between these two have been created. So now the onion proxy of the Alice need to extend this circuit. Only one part is there, so OR1 is currently the only one. It has to now create a symmetric key between Alice and OR2. But Alice cannot directly talk to OR2. So it will actually talk through OR1 only. So OR1, till the already circuit is created, it will send a relay cell to OR1, so that OR1 the relay cell will terminate and the command can be directly sent to this node. So it will now send from here a relay message, relay cell, and the circuit ID is already being used. The same circuit ID has to be used here. Now it will now encrypt, because already symmetric key has been created between OP and OR1. So that key will be used for encryption. And so the relay header, this is a relay extended header which will be there, which will say extend. So extend basically the telescopic encryption to OR2 now. So it will be sent by OR1 to OR2. So OR2 will never figure out what's the IP address of OP, onion proxy. So every communication to OR2 or anybody else will be always through OR1. So this is going through an extend. It will tell to whom the extension has to be done. It will be OR2. So Alice has specified, and it will send it knows the public part or public key of part of the onion key of OR2. So that will be used to send another random number, so that a symmetric key between OP and OR2 can be created. So I can call it G raised power X2 will be sent, which is in encrypted form. This is using the public key part of the OR2. So only OR2 can decipher this value, nobody else. Now this is encrypted for OR1, symmetric key. So OR1 receives it. It will decrypt it actually. So once it decrypts, it figures out that a digest is matching actually, because this is only being encrypted once. So once the digest matches, it will now interpret what is there inside the relay header. It says it has to be, there is extension request, it has to go to OR2, and this is the string which has to be sent. So it will now actually create a circuit using a command cell. Now command cell, remember, is always between two onion routers or onion proxies, or onion proxy onion router pair which are directly communicating. Okay, you cannot relay it. So here it is being relayed, and now there is a direct communication. It will send a create. Now there is going to be another, it will find out which circuit ID is still not being used here, because OR1 to OR2 route can also be used by somebody else for their own circuit. So any unused circuit number that will be used, and a routing table at OR1 will be created, which will say map from C1 coming from OP to OR2 with, and it has to be converted to C2. Okay, that's the only information which is available, nothing else. Okay, and while coming from OP, I have to do a decryption. While sending to OP, I have to do a encryption. Only that is the information known to OR1 as of now, which is going to be kept in the table. Now, once this create C2 is being sent, it will send also this information. Okay, now OR2 is being used by OR1 so that to whom to communicate. C2 is identified, and this thing entity is a data for the extension which is sent as it is. Okay, once OR2 receives it, it will be able to decrypt this one using its private key, and it will now generate another random number. It will send it back. It will be created, of course, confirmation. Circuit ID will remain same. It will send G raised power Y2, and of course hash of EK2 will be sent back the way it has been done here. So once it reaches here, so OR1 now knows that C1 as this extension has been created. Okay, it will simply now send this information back after doing encryption. It has to be relayed back now, and it knows C2 has to be mapped to C1. That's now in the routing table of OR1. You create C2. It will do the encryption with the symmetric key which has been already generated after this step between OP and OR1. So it will be now extended. That's a confirmation which happens. Okay, in the relay header, and it will now send the information back, and H of K2, these two will be sent. So extension has been successfully done. So Alice onion proxy will now decrypt it and will know that yes, extension has been done. So it knows now G raised power Y2, it already knows G raised power X2, it can now find out the key between OP and OR2. So now a path has been set up, OR2 is still not able to know what is IP address and port number of onion proxy. Okay. So Alice is still unknown to OR2. But Alice knows about everybody who is there on the way. So once this is done, but now my exit route is OR3. So I have to do something more. I have to do one more extension from OR2. So how that will be done? So we will, another request which has to go. It will again be relayed and it will be now has to be deciphered by OR2. So I will do a double encryption. Sorry, this has to be C1, not C2. So relay C1 and it will now do a double encryption. First encryption will be the key which has been now created after this step with OR2, and then the key which is being already being there with the OR1. So twice it will be doing. It will again make a request for extend, and this request now technically is for OR2. OR2 has to do this extension, and it will say to whom it has to go. It will specify OR3. It will also send using the public key part of the OR3. It will now do the encryption and send its own random string. So I can call it X3. And remember, it's a double encryption. That's why twice curly braces have been put. Once it reaches here, OR1 will decrypt it. It can't make any sense because the digest is not going to match. Once digest does not match, it will simply forward it to the next request. It will be now, will identify only with C1. It has to map to C2 and send it to OR2. It will simply do that. And decrypted part, it will simply transform because it can't understand what's there in the release payload. Okay, so it's one encrypted form. It will go extend. It has to be OR3. It's encrypted with the public key part of the OR3 actually. Now OR2 will be able to decrypt it, and its digest is going to match. Once the digest matches, it has to interpret what's there in the relay header. So relay command is now extend, so it has to do extension to whom, and this key has to go as it is. So it will now do send a command actually now here. Okay, because here the relay circuit is now terminated. Now the command has to be there for cell has to be sent for the extension. So now it will send again a create from here, and it will call create, and whatever is the circuit ID available on this route that will be used, let's call it C3. It can be any value. I just put it C1, C2, C3. So that came to mind, and it will now say create C3, and it will just simply transfer whatever was received. So neither OR1 nor OR2 knows about what is this value. This will only be now deciphered by OR3 using its own private key. Okay. Once that is done, it will now successfully create the symmetric key to be used with Alice. In fact, it does not know who the Alice is. It only knows that there is a circuit ID for this. I have to use this symmetric key. That's it. And C3 to C2, this knows only that mapping. It will just do another encryption round while sending it back. Okay. So none of OR2 and OR3 knows about Alice as of now. So it will send it back, and of course the response will be created. C3, it will be sending another random string and hash of K3 as usual as the way it happened earlier. At this point, now OR2 will now be further encrypting it, and it will now use relay because now X extension has been done. It only knows C2, C3 has been done, it's successful. It will simply now create a header, response header for the relay cell. It does not know it has to go to Alice. It can only just use this C2 and send the confirmation. So it will encrypt with its private, symmetric key which is being created with the Alice, and write extended, which is confirmation, and it will now send GY3 which has been received as it is plus H of K3, and this encrypted thing will be received by OR1. OR1 will also can't interpret anything out of it. It will simply C2 to C1, and of course an encryption, because that's the way it has been noted down in its routing table. It will now say simply send a relay message with C1 and double encryption. One more times it will be done here, and it will be extended. Rest everything remains inside the same. So G raised power y3 is only known to actually OR2, and it will be only known to this thing, but G raised power x3 will only be known to OR3 and the Alice. So they will only be able to get the symmetric key between OR3 and Alice, and they only can use it. So once it comes here, the circuit has been now created, circuit has been set up. So once the circuit has been set up, now you can using relay command, it can actually relay the command all the way to the exit router, which is OR3, and ask him to set up a connection to a website. Okay, so now the relay command which will be used will be begin to set up a TCP circuit actually. So it can now send from here the relay command. Circuit ID will remain C1. Now how many times it has to be encrypted? Once for this, and once for this, so 3 times. So first encryption will be with the symmetric key with OR3, then with OR2, and then whatever is with OR1 in that sequence. So outer one is with OR1, this is with OR2, this is with OR3. And then of course you have to tell what is the relay command and what are the arguments for that command will go in data. In this case it will be website to whom you want to connect. And of course these are the closer for encryption. Received by OR1. So digest is not going to match, so it's certainly not for it. So it has to now find out C1 has to be mapped to whom? C2, which has to go to OR2. So that's as per that routing table which is maintained. It will simply decrypt one layer and send that further. So it will just do the relay again. C1 is mapped to C2, so C2 will be there. Now layers will be, one layer will be taken out. Rest everything remains as it is. So this is the command and this is the data which is going to be there in the data part. So once it reaches OR2, OR2 also can't decipher anything because digest is not going to match. So it has to simply look, C2 has to map to C3 and send to OR3. It will do the same. Okay, so it will now send again relay. C3 comes from the routing table at OR2 and one encryption layer being removed. And it says the relay command is this, begin. And the website. So OR3 will decrypt it. The moment OR3 actually says the digest is going to match, so it will interpret what is the header. So header says you set up a connection stream to a website which has been given. Okay, so it will now set up a connection, it will negotiate a connection actually with the web server. So it's a TCP handshake will be done. So once TCP connection is set up, then after this, whatever is actually coming from here will be just routed there. You will not be sending begin actually now. You will be doing relay data. So that is the command which will be coming. So that relay data once it comes is simply take whatever is the payload and pass it on to TCP cell. In the reverse direction the same thing is going to happen. Whatever is coming has to be connected to, you create a relay C3 and data command, and whatever is the payload bytes came will just simply be put here and sent in the backward direction. Okay, so this is the way it is going to happen. Now let's move ahead further. So once the data comes in, connection has been clear, so it will send a relay. So begin has to be confirmed. So again there is a relay command. In this case it will be connected. Okay, and it will be closed. One encryption. Once it comes here, this guy can't figure out anything. The digest does not match it, at least not for him. So it will simply do a further encryption by looking at the routing table, and circuit ID will be changed to C2 and it will become connected. It comes to the OR1. OR1 also can't figure out, look at the routing table and send it further. So it comes to the LS essentially. So what the LS will do is Now there is going to be 3 times the encryption which has to be here. So digest will not match, it will keep on doing decrypting. It knows the complete sequence, so it will do in the reverse sequence. First of all using symmetric key with OR1, then symmetric key with OR2, and then symmetric with OR3. It will decrypt 3 times, digest is going to match, and it knows yes, connection has been set up, and now communication can happen. So it will just inform the browser that TCP connection has been successfully done. So socket is okay. Now you can start setting up. The third phase is now data communication, which will happen. So in this case, here the LS will now send, for example, get a page from that website. So connection has been done with the website, so it can send a relay message. So remember, this relay has to be done till the exit router, and then from there it has to be simply piped onto the web server. Okay, so relay C1, and now the command which will be sent, it will be encrypted 3 times. Okay, and it is a now data command. A relay command is a relay data which is being used, which basically means at the exit router whatever is there, is simply pipe it onto the TCP connection. It has already been set up. Okay, so maybe the command which has to go is only HTTP get and whatever other things, URI or whatever it is, okay, of the file which you want to access. This is what will be generated by LS. This comes to OR1, it can't make any sense out of it. Digest does not match. At best, it knows that C1 has to be mapped to C2 and sent to OR2. That's the only thing known. It comes here and it will just simply swap C1 by C2, remove one encryption layer, so only 2 encryptions which will be available. Inside command and whatever is the payload that remains the same. So OR2 will also not figure out, it will just remove one encryption layer, same thing, and it will just simply again do the relay. So this is an end-to-end communication being created between LS and OR3. So this C3, there is only one relay, one encryption layer now left. So OR3 will immediately retrieve, digest is going to match once it actually removes the encryption, and once digest matches, it has to look into what is the data, what is the command, relay command. It says data. So whatever data has come in the payload simply has to be sent to the server, and this command says HTTP get. Now server actually does not know who is the guy actually who is fetching it. OR3 also does not know. OR2 also does not know. Only OR1 knows which is this. Unless all these 3 guys are actually being accessed by any surveillance agency, they can't figure out who is talking to the server. In fact, these guys will also don't know which server is communicating. Only OR3 knows that to which server the communication is happening because it is acting as a proxy. Okay, so only OR3 you can figure out. And as I know, if you can do traffic analysis here and traffic which is being generated here, and somehow you can match the statistics. So you can kind of get a circumstantial evidence of this being related to this exit node. But because you are changing every 1 minute, this becomes extremely difficult to correlate. Now the HTTP response will be sent back by the server. So once it comes, it knows that this particular circuit, TCP circuit, has to be mapped to this. It does not know for whom actually it is as of now. It only knows that I have to send it through relay. That's the only information. It will just do C3, encrypt the HTTP response. It will also now make it a data. Actually, it's a relay command is data here. Data has to be simply passed on, and response, the payload part will contain HTTP response. Okay, so it will come to OR2 also does not know anything. It will simply further encapsulate it after one more layer of encryption. This will become C2, sorry, and one more. The command and the payload part remains as it is inside the relay header and relay payload. So OR1 will also do the same thing. It can't interpret anything out of it. At best, it can simply relay it back as per the table. And there will be 3 layers now. The HTTP response is now being received. So now this actually Alice knows that I've used 3 onion routers to go to the website. So she will actually do 3 times decryption in the same order, and after that the digest is going to match. So it immediately knows that there is no problem. It will now go the HTTP response is a relay data. It will simply pipe this response to the browser which is connecting to the onion proxy. So your browser will start doing browsing anonymously over the internet. So nobody on the internet knows who is browsing, and you are browsing anonymously. No intermediary knows except your next guy. But what you are browsing is not known to anybody actually. Now this digest mechanism also provide, as I told, that it is possible that if you do traffic analysis here, and if you do traffic analysis here, what Alice is, whatever is exiting from Alice, if they are matching, I can actually kind of correlate them, and then figure out that what most likely you are browsing. That's a statistical analysis that also can be broken. So this actually provides something called leaky circuits. Okay, so in this case, what you do is you not only actually transmit data for this, you can transmit for data for some of the circuits. For example, you can, instead of doing twice the encryption, only thrice. In this data only you do twice actually. In fact, when you are setting up the circuit stream here, okay, so when you are doing this begin, so instead of, if I actually start, instead of doing encryption thrice, if I do it twice, it will exit, it will actually exit here. Okay, and then if here actually if I give begin connection, so it will set up a TCP connection from somewhere here. So it will now remember that C2 whatever is coming, this circuit, this particular stream ID has to be connected to here. Now remember this begin is mapped with the stream ID. So there is one stream which can go all the way here, one stream can exit here, one stream can exit here. So my traffic here will be different than what you are going to measure here. It's going to be very difficult from where things are emanating, and you can't correlate it. So it becomes extremely good in actually maintaining anonymity. Now important thing is that this additional header can only be interpreted at the destination node, nowhere else. That's very important, and depending on how many layers you have done, you are deciding which one of the intermediate nodes is going to act as an exit node. Okay, and of course if there is somehow the digest does not match and you don't have any information of how to forward it, okay, if OR3 does not know there is a thing and you send a relay data which is terminating here, and my digest is not, in fact digest is not matching, you don't know how to map it further. In that case, simply you have to, this circuit has to be dismantled. It will simply send failure. Okay, it will simply send abort, and then this particular circuit will be dismantled and new one will be created. Okay, it will say destroy control cell will be sent back, and it will be teared down. Similarly, in the reverse direction, if this thing happens that your digest does not match after doing 3 times decryption, it will simply tear down the whole circuit. And of course, not only this, we can do incremental destruction also. Okay, this is done through truncation. So if for example I want to truncate this particular part, so this dot 3, so in that case if the truncation has to be done, Alice can send a relay truncate message. So it will be, it can send a relay on the same circuit ID, and it only does twice the encryption. So OR2, after that the truncation has to happen, and it can send a truncate. Okay, and the truncate message has been done. So this will go here, from here, and then again this will be mapped onto, because after one encryption is removed, it can't make sense out of it. It will simply map to C2, and it will go with truncate. It will reach here, and now it can interpret this as a truncate request. For C2, it will remove from that routing table entry, and it will also send a command for, in that case, for tearing down the connection. So remember, there was, when we are looking at a control cell, there was third command which was destroy. It will send a destroy thing, and destroy command will keep on send. So all the circuit will be cleared after that. And once this is truncated, this is the only point. Now Alice need to remember this is that has been truncated and this circuit ends here. So it can do a further extension in some different direction. So it can dynamically keep on destroying or truncating and keep on extending in a different direction. So that possibility do exist. That gives a lot of flexibility. And of course, there is one more thing. If, for example, this node OR3 goes down, then what is going to happen? In that case, the previous node will figure out this node has gone down, okay, and it can actually, it will send a truncated response, can be sent back to the Alice, and this routing table entry can be purged. And now Alice will know, okay, the truncation has happened from this node, so my circuit is only up till this point, and it can start an extension in different direction, or will only use this as an exit route. Okay. Now the one of the important thing, there is one attack. For example, I can just simply take down one onion router node. So this will break down the circuit. Now that is taken care of, because the earlier guy will send truncated, and I can actually now extend in different direction, then start again accessing the internet anonymously. So that you break a node and circuit goes down, that kind of attack can also be taken care of. So normally idea here is that this was done for the browser. It can be done for any application actually. You can do telnet, so you need the Tor project.org gives only the browser which runs over the Tor, but you can actually integrate Tor library with any application. So normally any application you don't have to do much modification. You can use SOX proxy. Okay, the application can connect to SOX proxy. And using this SOX proxy, you can connect to Onion proxy actually. And this will then create all the Onion circuits for you, and then you can connect to the server on the other side. Okay. And leaky circuits can be used to ensure that you can break down that traffic correlation attack. And this is how basically this whole system works, and it can work for almost anything. One of the problem which remains is the speed. Okay. So how to handle the speed, because this mostly network is very slow. So I am not going to go into details of this. So next video I will be talking about hidden services, or what we call the darknet websites, how those are actually gets created, and nobody knows that where these darknet websites are actually being hosted. So we will look into that, how that thing is done. That's also a very interesting design which has been implemented in the Tor system.